attendees are in listen-only mode.
Aloha, this is Howard Wigg in sunny Honolulu, and I'm joined by Eric Makala in maybe sunny Boise, Idaho. Eric is the Hawaii State Energy Office's energy code consultant and has been a tall figure in the energy code world for a long, long time. Eric and I were at national code hearings recently for the 2018 IECC, and there were hundreds of proposals that we were testifying on, and I swear Eric was probably up at that microphone every 4 or 5 proposals because he represents so many different entities who are depending on him to get the best possible codes for their states or municipalities. He is a major figure, again, in the energy code world. I, Howard Wigg, have been with the State Energy Office for a long time and was in on the very first energy codes that evolved, pale shadow of today's codes, needless to say. And I likewise am a regular participant in the National Hearing Code as we develop codes every 3 years. And my specialty has been the development of a whole new climate zone, the tropical climate zone, that just got into IECC 2015, which is what we're discussing today. And that gave us pretty well a blank slate to work on in devising codes specifically for Hawaii's unique climate. And that is especially evident in the tropical code for residences. The current topic today, commercial building lighting and electrical requirements are not affected by the tropical code. But that's just a bit of background about me. These are the 2 people you will be listening to. Next slide, I believe, is the Jolene slide, Eric.
Great. Okay. Thank you, Howard. And as Howard said, I'm Eric Makala, and I'll be the co-presenter with Howard. What we'd like to do today is Howard introduced himself and myself, and so you kind of know a little bit about us, but we want to find out who is in the audience. So the first thing we're going to do is we're going to take a poll, and for those of you that have been on other webinars this week, it'll be the same thing we've always done. So we're going to go ahead, and if you can pick the profession that most closely represents you, and if there's not one on here that represents you, then there's an other category, and that normally is seems like that's going to be one of the predominant ones that we've seen. So I'm going to go ahead and launch the poll, and as soon as I do that, you'll have the ability to go and answer the question. So I've launched it, so go ahead and select your profession, and we'll see who we have on the phone here. I'll give you about 30 seconds or so to do this. Normally people are pretty quick. So we've got about 85% of you that have voted so far. Now we're at 90. We're moving right up, so hopefully we'll be at 100% fairly quickly. But I might cut this. Oh, here we go. We are now at 100%. 100% voted. So I'm going to go ahead and close the poll, and I'll share the results with everyone. And kind of what I expected, the majority of you are classified yourself as an engineer. So I'm going to assume you're probably an electrical engineer dealing with lighting systems. Or one of the trades that deals specifically with that. 25% architects, which is great. We definitely like to have architects on all of the energy code classes because energy codes impact your entire design. So it's great to see you on here. From a jurisdictional standpoint, about 10% plan review and inspection staff and building officials, so this is great. And then the other 25% of you classified yourself as other, and from what Howard and I can figure out, that probably means that you are a material manufacturer or a material supplier, consultant, maybe utility representative, but kind of someone that falls underneath that category. So we welcome you all on here. So thank you very much for doing this. Now let's get back to the presentation. And we are going to be taking questions today. And what we've asked, what we want to ask you to do is we're going to take questions at the end of the session. But if you have a question, please email it to the website or the email address that you see here, jolyn.green@cadmusgroup.com. We'll go ahead and run through the entire presentation, and at the end we'll take questions. If you want to go ahead and write this down, that's great. If you don't want to, we will have this exact slide at the end of the presentation, so you can go ahead and just go ahead and type it in with the question at the end of the session today. But with that, Howard, I'm going to turn it back over to you, and let's keep going.
And we do love questions. This is your webinar. You are going to be the people who are living with this code in the not awfully distant future, and ask questions. This is for you. We love questions. Speaking of which, when will the 2015 IECC be adopted in Hawaii? There could be a long answer, which I won't bore you with, but the short answer is that the code should be in the adoption mode either at the state level or at a couple of county levels by the end of this year, with the remaining counties following next year. That said, there is no reason whatsoever why you should not be using this code right here, right now. There's nothing wrong with going beyond the existing code. You're aware that we are still under 2006 IECC. This code is approximately 33% more efficient than the 2006. So in my unbiased opinion, if you're still following 2006, you are doing your clients a disservice by not taking advantage of all the advanced technology that's gone on in the interim years. So can we have the next slide, please? Okay, structure of the code. There's very logical structure to any code, and it all looks like this, be it the fire code, electrical code, whatever. You first have to start with the scope. Where are the boundaries to this code? Very useful piece of information. And who's going to administer it, and how does it get administered? It looks like kind of a boring section, but when you really get into it, it's a very essential section. Then we have definitions. If you go to your doctor's office or hear doctors talking, they have a specialized vocabulary. If you've been in a courtroom and the attorneys are arguing, you'll find that they have a very obtuse vocabulary. And likewise, us code people have a specialized vocabulary. We often use what would be common words in an uncommon way. That's what the definition section is all about. Then the general requirements, and my favorite part of the general requirements is the delineation of climate zones. And every county in America is assigned a climate zone. So this goes on for page after page after page. For instance, I think Texas has they may have 4 climate zones and a zillion counties in Texas. But Hawaii is very fortunate because we lead this whole climate zone section with something called the Tropical Climate Zone. And this is a project that I worked on long and hard and had many, many, many allies, including from the cold climates, to establish this, because we have struggled over many years to fit the best possible design of buildings and homes into the mainland code, and it's been like trying to get a round peg into a square hole. So with the Tropical Climate Zone, we pretty well have carte blanche to design as we please. Now that's, to me, a very important part of the whole code. And then commercial energy efficiency. This is where we get into the nuts and bolts, or the meat and potatoes of the whole code. And then we have existing buildings. We have always covered retrofits for existing buildings in the codes, but with 2015 we gave it a whole new section, and that includes a re-roofing section, and that has caused the most questions to date. I've worked very closely with the Hawaii Roofing Contractors Association on this, but that's outside of the scope of this particular webinar. And finally, we have reference standards. The code refers to ANSI, NIST, SMACMA, Lord knows what all, and it simply gives the acronyms for those organizations. And that's, if you need to find out what in the world NIST stands for, you can go back to the reference standards and read all about it. So next slide, please, Eric. Energy savings potential. First, there's residential savings, commercial savings, and then on the right, the two added up in orange. And this goes over, it projects the savings over a 20-year period. And energy codes are the gift that keeps on giving. Because, say you build X number of buildings to code in year 1, we assign a 20-year life to the projected savings. Why? Because the equipment in a building lasts less than 20 years, but the envelope in a building will last, say, at least 30 years, if not 40, 50, 60 years. So we take 20 years as a conservative average on that. And when you estimate savings, you don't just estimate the savings for the first year because you built a nice efficient building in year 1 or home, and that savings transfers over to year 2. Everything's still the same, and year 3, 4, 5, 6, 7. So the savings from year 1 is X times 20 because you're projecting savings over 20 years. Then comes year 2, here comes some more efficient buildings, and to go out to the 20-year end, you go X times 19. Year 3, X times 18, so forth, so forth, so forth. So the cumulative savings at the end of 20 years is an exponential number above the first year's savings. And look at that, 4,703 gigawatt hours 20 years from now. This assumes that the code started this year, which it didn't, so you can slide that back a year. And what is a gigawatt hour? It's enough power to turn the lights on and the AC in about 200,000 homes for 1 year. Think about multiply those 100,000 homes times 4,703, and you have got some tremendous savings. The payback time and the cost effectiveness of codes is just astronomical. And maybe I should insert here that when we at the national level propose new code measures, we always take into consideration cost effectiveness, always. And if we don't, the builders are right there to correct us on that. So next slide, please. We've been through, well, first we did 2 residential webinars, and then this is the last of the 3 commercial. First was envelope, then HVAC, and today lighting and electrical. And that goes as a logical reason for that, because the way you design the envelope of your building directly affects the sizing and the distribution of your HVAC system and the nature of your lighting. For instance, if you have a nice tight envelope that in Hawaii keeps the sun's heat out, you can downsize your HVAC system. And if you have a lot of windows that emit just light and not glare and heat, you can make provisions for having a lot less lighting on during the daytime hours. So next slide, please. And general, this gives the overview of this section. Not a whole lot to say about that. So let's jump right into the next slide. Give you plenty of time to talk here, Eric. There are three ways of complying with this code. Number one, the ICC and ASHRAE work very, very closely together, and ASHRAE precedes the ICC codes always. So the equivalent to IECC 2015 is ASHRAE 90.1-2013. And this is not just an arbitrary comparison. One of the Department of Energy's national laboratories, Pacific Northwest National Lab, which Eric worked for many years ago, I believe, does a very, very careful analysis comparing the current IECC code with the ASHRAE code, and says this section's a little up, this section's a little down, and in the end, it's pretty well a wash. They are equal codes. So if you want to follow ASHRAE, you're perfectly that's perfectly permissible. Then, following IECC, you get to the prescriptive codes. This is where there are precise numbers to follow, and the vast majority of people follow this path. However, some more creative or original types want to design their own building, and it wouldn't fit into the prescriptive formula. So what they do is first model the building according to the prescriptive formula and find the estimated energy use of that. Then they design according to what they want to do, and the end product of their energy use must be equal to or less than the prescriptive number. Again, not too many people do this, but the architects especially insist on having this provision, and it allows for, again, a lot of creativity, a lot of original building design. Next slide, please.
All right, I think this is my slide, Howard. So I'll.
Yep, you can take it over. Yep.
I will run with it from here for a while until it's ready for you to jump back in. So.
Okay.
So Howard laid a great groundwork on what's going on with the codes and what's going on with the envelope requirements, mechanical and things like that. And there are, as Howard mentioned, I mean, a 33% increase in efficiency between the 2006 code and the 2015 IECC, and a lot of advances and a lot of efficiencies were actually made in the lighting section. The 2006 code actually had, as I kind of reviewed the both codes, there's parallel types of provisions in there, and what we're going to be looking at are lighting control requirements, which you currently have in the 2006, except the 2015 kind of takes it one step farther, and lower lighting power level densities. I was just doing a comparison as Howard was talking between the, for example, what you currently had for office lighting versus what we have in the 2015 code, and in the 2006 office was at 1.0 watt per square foot, whereas the 2015 office is at 0.82 watts a square foot. So it was a pretty good drop on that. But what we're finding out here is actually lighting designs are coming in significantly less than what the lighting power density requirements are in the 2015 code, with the sheer number of LED lighting that's being used. And Howard can get into more of this when we get into the lighting power density requirements. But they're basically the designs that are coming in right now are significantly lower than even what the 2015 code requires. And actually, when the 2018 comes out, you'll see lighting power density numbers that actually reflect much more of the LED lighting than what we currently have right now. So the other kind of a theme for the the lighting power systems or lighting systems is taking advantage of daylighting. And this is happening both in the lighting requirements of the code and also in the building envelope. Those two parts of the code kind of work hand in hand. And from a design standpoint, the design teams really need to work together to make this work. There'll be some instances where you'll be required to install skylights for the building envelope. These are essentially spaces with a lot of roof area, and the requirements underneath those skylights will be automatic daylighting controls. So the lighting designer and the architect have to work to really have to coordinate very closely on this in order to make sure that you're getting the design correct on this, and that the right controls go in. The lighting designer knows exactly what's going on with that building. There's also a requirement that we don't talk about much in the 2015 code that actually requires the someone, whether it be the architect or the lighting designer, to actually put on the either reflected ceiling plan or the lighting plan where you're assuming your daylight zones are. And so this makes it easier from a jurisdictional standpoint to get a better sense of what lights have to be controlled by automatic daylighting controls because they're in a daylit zone. So that is actually in, Howard talked about the scope and application. This actually falls underneath the scope and application section of the code. So I just wanted to you to be aware of that as we move through here. So with that, let's start to jump into what the requirements are, your new requirements. And you're going to see a lot of familiarity with things that are currently in the code right now, except again, this is going to take it one step farther. So the first specific requirement is the occupancy sensor controls. And under the 2006, you could install occupancy sensors for automatic lighting shutoff. That would be through occupant intervention. Now the code actually requires you to install occupancy sensors in certain space types. And this has been in the ASHRAE standard 90.1 for the last couple of versions of the ASHRAE standard. It's finally really truly made its way into the IECC as a true requirement. And when you start looking at, you're looking at the kind of the green box, the occupancy sensor controls and where they're required, you're going to notice the types of spaces where lights are typically left on. So, for example, a private office, someone has their lights on in there, they step out, they forget to turn the lights off, and so lights can be left on in private offices quite a long time, locker rooms, restrooms, lounges. There's always the old adage and the old story about having an occupancy sensor in the restroom and someone's going to the bathroom and the light turns off. And I mean, there's different types of occupancy sensors that you can get that will make sure that isn't going to happen, but it always makes for a great story. Warehouses are also required of occupancy sensor controls. So you'll see a whole shopping list of occupancy types that will actually be required to install occupancy sensors. From a warehouse standpoint, there are occupancy sensors are required in warehouses, and you can see the middle, the sensor control function on the center box here, if you will. Actually, I guess the right-hand box talks about the warehouse control function, but when you're installing occupancy sensors in to comply with the right-hand box where you typically have to put it in, there's some requirements. For one thing, that the lights are turned off automatically after 30 minutes of occupancies leaving the space. And actually, I'm not sure where 30 minutes came from. This could probably be reduced to 20 minutes. Actually, I believe there was a proposal that went in at this code change hearing for the 2018 code that I think tried to reduce the 30 minutes to 20 minutes because it's why 30 minutes? Why not less than that? Why not go ahead and shut it off a little bit sooner? But right now, the occupancy sensors have to be designed to shut off the lights within 30 minutes. You also need to be able to have to have a manual on to control the lights in that space. So it'd be a manual on and automatic off. And if you don't have the manual on, then if the occupancy sensor actually turns the lights on, you can't turn it on to more than 50% power. And then you can always increase the power, obviously. But so there are some requirements on how the lights are to be turned on in the space. Manual on, though, if there's already enough daylight in that space, for example, or enough light in that space, you don't need the light to come on, then it's up to the occupant to turn the lights on using a manual control.
And Eric?
Yes.
Yeah, let me jump in here and say that I've seen at least 3 or 4 studies of warehouses. You're wondering why in the world so much time on warehouses. They are intermittently occupied. They may go for hours every day with no occupancy, and then say a forklift comes in to get a load, and he is only going down one aisle when this warehouse may have 10 aisles. In this case, with the sensors, you could just illuminate that particular aisle. So I've seen 80% savings, even 90% savings, and as I'm looking at this, I'm thinking this is just a great application for daylighting.
I agree.
All that high ceiling, and you can just daylight the heck out of it, and then you can overcome all of these artificial lighting requirements.
Right, and actually, so a warehouse, Howard, that's a great thing to good lead into the requirement that's actually in the building envelope requirements. It requires you to have top lighting or daylighting in a large roofed area, and warehouses would fall underneath this. Any non-refrigerated warehouse. So in that case, you're required to actually have 50% of your daylit or your floor area in daylit zone, and also be required to have automatic daylighting controls in the daylit zone. And then so this requirement would actually require an occupancy sensor in addition to the daylighting controls, so that if there's enough natural light in that space, the occupancy sensor in this case would, I guess, only turn it on to 50% power, or the occupancy sensor would kick the lights on, but the daylighting control would actually dim the lights down to what you need from a foot candle standpoint, to make sure you have adequate light in that space. So the two controls in this case would be working hand in hand to be able to provide the right level of lighting for that particular space. And actually there is a new provision in the code, a new technology out called a luminaire level lighting control that actually has the controls, each fixture actually has an occupancy sensor and also a daylighting control built into each fixture. So the fixtures can actually operate independently, and something like that for a warehouse design would actually work quite well, because every fixture again would operate independently from the other fixtures. So there's now, if this goes through in the 2018, a path for technology like that to actually get it in, and there's pretty significant energy savings even over these types of controls using a luminaire level lighting control. So the Northwest Energy Efficiency Alliance has been doing a lot of work, which is that they represent the Pacific Northwest states. Been doing a lot of research on this and are promoting it heavily in the Northwest as an option for lighting controls. So again, there's going to be areas where you're going to have to install occupancy sensors, and there's some criteria on those occupancy sensors, and then you'll have the warehouse specific warehouse requirements too on how those are supposed to operate. So with that, let's go ahead and move on. So in the again in the 2006 code, you also have a requirement for automatic lighting shutoff that we briefly mentioned. And the automatic lighting shutoff control in the 2006 was either using a time clock, or it was using an occupancy sensor. So the way that this code is structured right now is if you're in spaces that are not required to use that don't have an occupancy sensor, you actually have to have a time clock control to be able to turn the lights off on a scheduled basis. So basically, you could put occupancy sensors through the entire building if you wanted to do that. But if you didn't want to do that, then it would have to be, again, on a scheduled basis, some kind of lighting control system that would automatically turn the lights off during non-occupied hours. And there's some criteria for that. So basically the same requirement as you have in the 2006, except again, you're going to be required to put in occupancy sensors in a lot of occupancy types, and where you don't have that, then you installed an automatic time clock to be able to shut the lights off. Okay, let's keep going, and we'll talk about light reduction controls. Currently in your 2006 code, you have a requirement for I call it bi-level switching. It's basically being able to reduce the lighting load in the space by at least 50%. And so if I have two lights in the space, I basically have to control part of the lamps and the light in the luminaires on one control, and have another control to operate the other luminaires. So I can have reduce my lighting level by 50% in that space. And so the requirement has not changed based on what you currently have in the 2006 code. The requirement is still to reduce the lighting level in a reasonably uniform illumination pattern, which is essentially you don't want half the room light, half the room dark. You want, if I've got 2x4 fixtures in the ceiling, say 3 lamp fixtures, I could actually control the center bulb on each one of those fixtures on one control, and I could control the outboard bulbs on another control. So I can either reduce the lighting level in that space either by 33% by switching all the interior bulbs off, or by 66% by switching the outer bulbs off, and that satisfies the requirement to be able to reduce the lighting load by at least 50%. So this, again, the requirements haven't changed, and there's a few options here for the light reduction methods that are included on here. I know there was an allowance to use a dimmable control in the 2006 code. I believe you can still do that for here, just a manual dimming control, if you have a dimmable ballast for those types of fixtures. So that's still a requirement. But the key, again, is uniform lighting reduction. So you want to be able to bring the level uniformly down through the entire space, and again, not keep part of the space dark and part of the space light. And there is no exact science for how this is done. From a design standpoint, it's always a challenge to figure out how to do this. From a jurisdictional standpoint, it's always a challenge to review the plans to make sure that they've done it correctly. But again, this requirement hasn't changed. Now, the only exemption on this is if you have a space with a daylighting, a daylit zone in there. I'll talk about daylight zones in the next slide. Then you are not required to have bi-level switching, because the daylight zone requirements, the daylighting controls will all automatically do this for you. And it'll automatically dim the lights if you have sufficient light coming in from the outside to be able to light the space on the inside. So, yes, Howard.
Just looking at this requirement and thinking about the fact that the LEDs are coming on like gangbusters, dimming might be the best option for this, because it's a whole lot easier to dim LEDs than it is to dim fluorescence.
Absolutely, yes, yeah, absolutely. So I think with the new technology coming out, this will be it'll be a lot easier to comply with than what we've had to do in the past. So great. All right, well, let's keep on moving and talk about, I've kind of mentioned daylight zones, and the first thing I want to do is I want to go ahead and define what we're talking about as a daylit zone. And daylight zones first actually came into the 2009 code, I believe, was the first time we started to actually see requirements for controls on here. And then it's progressed as we've worked our way through codes and probably become a little more complicated. The 2015 or 2012 code actually is probably the most complicated for lighting controls, and the 2015 lighting control requirements were actually completely revamped by a proposal submitted by the International Association of Lighting Designers. Actually submitted a large code change proposal to try to clean up a lot of the language. Earlier codes, you used to have the option of manual controls in daylight zones, and in this current set of requirements right now, you are required to put in automatic daylighting controls in daylight zones. So a daylit zone, by definition, is essentially you've got two types of glass in your building. You have vertical glass, basically windows, which the code refers to as a side light. And then you have skylights, basically glass in your roof that the code refers to as top lights. And a daylit zone in front of a window is going to be from the surface of the window back 15 feet and then 2 feet on each side of that window. This type of requirement has been in California's Title 24 Energy Code for years. It's just finally made its way into the International Energy Conservation Code. So again, from the surface of the window back 15 feet, and then 2 feet on each side of that window. Now, the other thing is if you have a floor to ceiling height partition that is less than 15 feet from that window, then the daylight zone stops at that floor to ceiling height partition, because obviously there's no light, natural daylight that's going to be able to get on the other side of that partition. So it can get a little bit complicated on how you define your daylight zone, but the nice thing is the IECC actually has several diagrams to say here's how you define your daylight zone for your particular space. So from a side light or a vertical glass standpoint, that's how you defined it. So for a typical skylight, though, the way that it is calculated out is you take you have the dimension of your skylight, and you also have the distance from the floor to the ceiling and your ceiling height, and it's 0.7 times the ceiling height. So basically 70% of your ceiling height, and you take that dimension and you add that dimension to each side of the skylight. So if I had for example, I'll try to do the math quickly in my mind. If I have a 10-foot ceiling and I have a 4x4 skylight, 0.7 times 10 feet is 7 feet. I add 7 feet to each dimension of the skylight. So when I project that daylight zone down to the space, it's basically an 18 by 18 foot area on the floor that becomes my daylight zone, and all the lights that are in that daylight zone have to be controlled by an automatic daylighting control. So again, you're projecting your daylight zone down to the floor area. There's also provisions. We have things like roof monitors, and the daylight zones on that are calculated out slightly different. So you'd have different configurations of how the skylights are actually designed into the roof assembly, whether it be a roof monitor, a normal skylight, that type of thing. And so again, the diagrams are pretty good in the IECC to make sure that it gives you clear guidance on how to go ahead and calculate this out. The spaces we're looking at, as you can see on the slide, are spaces with a total of more than 150 watts of general lighting within the daylight zones. So this is kind of the key, either on the side light zones or on the top light zones. And so you can see the two diagrams we have. One is actually a waiting room, and you have side light area, and that whole space on the top picture is actually in daylight zone, back to the wall behind the looks like behind a counter, and then more of an industrial space down below with you can see skylights in that, and it does a great job of illuminating the entire floor. And again, the key thing with here is you need automatic daylight responsive controls in all of these zones. So Howard, why don't you go ahead? That's kind of it on the control requirements. So Howard, why don't you start talking about the lighting power density requirements?
Absolutely. A little comment on daylighting. The formula that Eric just ran you through is complex. That is absolutely true, but on the other side of the coin is the fact that we Homo sapiens have been on the planet for about 200,000 years, and our hominid ancestors, the people who first started walking on the ground rather than swinging in the trees, have been around for, last calculation, 5.2 million years. And we were outdoors virtually all of that time until Mr. Edison invented the light bulb only, 150 years ago. So our genes and our visual system is totally attuned to the daylit environment. So we feel better under daylight, we see better under daylight. So that's just a spin-off of daylighting advantages. That said, look at the lighting power densities in this facility, and if you have been keeping up with LED design, you are possibly saying to yourself, I can go below that, I can go below that. And indeed, I have friends in Seattle, electrical engineers, who are designing down to less than 0.5 watts per square foot. And one fellow who's really advanced is going, I think he said he was going down to 0.3, you add controls to that, and you get an incredibly efficient lighting design. Just as a sidebar, some people are saying, why don't we amend the codes as they go through the state or the municipality process and say that if you can design 30% below these lighting power densities, then you are exempt from a lot of the daylighting and controls requirements, because when you get to lighting power densities that low, the total share of the building energy consumption becomes not minuscule, but just a tiny slice of what it used to be. So what you'll see here in these lighting power densities is, I think we went down about 20%, 15 or 20% from the 2012 IECC iteration. And again, this just reflects LED technology. I recently read a report from one of the major LED manufacturers in the factory under ideal conditions. They are now burning and testing an LED diode that yields 200 lumens per watt. And it's typical for larger LEDs these days to be over 100 lumens per watt, even 120. This is off-the-shelf, cost-effective technology already, and it's going nowhere but up. Cost is going down. So anyway, let's go to the next slide, which is kind of more of the same. Oh, this is the that's the whole building type. And then if you want to design space by space, then you go to this design and you'll find that the lighting power densities are slightly higher. Then you get into some very interesting differences, like performing arts. It gets a very high lighting power density, because if you're, say, a fan of the opera the way I am, you know that lighting is very, very important, and you need to give huge splashes of color every now and again. Another example of high lighting power density would be in operating rooms. You certainly want to let the doctor have all the space he needs to take out your appendix, and ditto for other type medical facilities where visual acuity is very, 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 very important. Otherwise, these lighting power densities likewise are going down, and my electrical engineer friends say this is pretty well a piece of cake already. Another benefit for Hawaii is that the lower your lighting wattage, the less heat is produced, the less load there is on your AC system. So let's go to the next slide, Eric.
Great. And Howard, I want to add on here too. The classes that I've taught a lot quite around the U.S. on these types of things, and we, Howard and I were teaching in Hawaii in November, and there's always the comment that comes up that can we achieve the foot candles we need in spaces with these low lighting power densities? And it's the key thing is that the lighting power densities are dropping, but you're still getting the same amount of light out of that bulb. It's just not costing as much. You're not being penalized with the high amount of wattage it takes to drive that bulb. So you still can maintain foot candles very easy, even with lower lighting power densities, because the technology that we're using right now is so much more efficient than the technology we used before. So it's and the Illuminating Engineering Society in North America. These are actually numbers that came from the ASHRAE standard. So ASHRAE uses the identical lighting power density numbers, and these go through the ASHRAE lighting committee. And IESNA is represented on that committee, and they've kind of said, yes, we can do this. So let's go ahead and get the code. So.
Yeah, I've been president of the Hawaii chapter of IES for more years than I can count, and I can ratify that. In fact, the ASHRAE standard is called the ASHRAE/IES standard, because the Illuminating Engineering Society is totally integral to setting these numbers, and these are the people who specialize in visual acuity. I've dealt with a lot of them, and they really know what they're talking about.
Great. All right, so I will. I'm going to jump into exterior lighting now, Howard, and I'll talk about that. So, in the 2006 code, you actually have requirements for exterior lighting, and it's basically it's based on the type of use on the outside of your building, and those uses haven't changed between the 2006 and 2015. The biggest difference that has changed is how many watts per either square foot or lineal foot of use that you can have. And again, this is going to reflect better lighting technology being used on the outside. The other change that's going to be on here is that you now have to pick your exterior lighting zone. And this, because you don't need, you need more lighting in a high activity downtown area than you do next to a national park. So the higher the number of zone you're in, the more lighting you can have on the outside. But if you can see lighting zone 1, for example, you don't get a lot of lighting on the outside. Lighting zone 4, you do. And this is going to mean that you need to, as a designer or as a jurisdiction, kind of define your lighting zones to say, okay, downtown city corridor, we're going to allow you to have zone 4 lighting, and we'll show you how this plays out in the next slide. But if we're next to a national park, then you only get you're going to be able to get less lighting. And so you, as a designer, will need to pick which lighting zone you're in, and as a code official, you're going to have to make sure that the lighting zone that you select actually makes sense for the project and where it's being placed. So the first step now is actually to determine your lighting zone, and then the next step is, once you have your lighting zone, you're allowed, based on zone, either between 500 to 1300 watts of lighting, just base lighting based on your zone. And then you have to go ahead and select, start to calculate out how much lighting you need for each of the uses on the outside, whether that's going to be, in this case, we have parking walkways less than 10 feet wide, and in zone 2, for example, you're given 0.7 watts per lineal foot of walkway. So you basically define, you look at your exterior plan, figure out how much lighting you need for each of the uses on the outside, total that all up, and that becomes your budget for the exterior of the building. But that is strictly based on your lighting zone. So if I'm at a downtown city corridor, for example, I get 1300 watts. If you look at the far right-hand column, 1300 watts automatically, and then I can calculate out, based on the uses of whether it's walkways, entrances, and things like that, calculate out how many additional watts I get in addition to the 1300 watts, and then that's my budget, and then I just need to design my plan around that budget. There's also what we call the non-tradable or use it or lose it type of lighting, and that would be, they call it non-tradable because it's for specific uses, like ATM machines, for example. You can have a specific amount of light at an ATM machine, but if you don't have any ATM machines, you can't take credit for that. So it's only, and the lighting has to be installed at that ATM machine. So they're specific. Again, just you've already had this in the 2006. It's carried forward in the 2015 code too. So just kind of one more level of complexity as far as making sure that the lighting is tailored to what's going on in that area and the kind of the region you're on, the neighborhood, this downtown city or wherever you're designing your lighting for.
Yeah, Eric?
Yes.
Yeah, I've discussed these lighting zones with engineers here in Hawaii, and there's general agreement that the only Zone 4 applications would be downtown Honolulu and Waikiki. Other urban areas in Honolulu or the neighbor island towns would be probably Zone 3. And of course, residential would be residential. That's not set in concrete. That's just the result of our conversations.
Okay, great, good. It's good that you're already looking at that, and things are, just to make sure that they're, because the thing that'll make this work is if the jurisdictions actually have a general idea of what they're going to allow where, basically define the lighting zone. So if a lighting designer comes into the and says, okay, I'm putting my project at wherever, the jurisdiction can say, okay, here you're going to be lighting zone, lighting zone 2 or lighting zone 3. But kind of have some predefined lighting zones within your jurisdiction. And that way it eliminates confusion, eliminates arguments at the counter too, as far as, what zone you're actually going to be putting in. Because we've had scenarios where someone has cited they're going to put a retail building in a residential area and they want lighting zone 4, which doesn't work when actually it should have been, lighting zone 2, for example. But they submitted it as a lighting zone 4, and the building department said, no, you can't do that because we don't have any lighting zone 4 anywhere in our small town. So again, it's just better to kind of get this set up front so you know exactly where the lighting zones are, and it'll just eliminate a lot of confusion and a lot of arguments. So, okay, with that, so we've talked about interior lighting control requirements. We've talked about lighting power density requirements. We've also talked about exterior lighting power density requirements. And there's a lot of energy savings in the code from lighting controls. Occupancy sensors, daylighting controls, automatic lighting control systems that shut lights off during the scheduled periods of time. So we're getting a lot of energy savings with lower lighting power densities, but we're also getting a lot of energy savings with our lighting controls. And the one big thing about lighting controls is you're not going to get the energy savings unless the controls are set up properly. And this is kind of the key thing. So the new requirements in the 2015 code actually require you to have to do functional testing to make sure that the lighting controls are actually set up properly. If you have daylight responsive lighting controls, to make sure they're actually put in the daylight zone, so they actually operate the way they're supposed to, and they're set up to be able to actually dim the lights the way they're supposed to and as designed. And this is going to be a key thing to making sure that we're actually getting the energy savings that we need out of these lighting controls, because we've seen really bad examples of lighting control systems put in spaces that don't function properly, and there's complaints by the occupants. The lights, they don't dim when they're supposed to, or they dim when they're not supposed to, and that type of thing. And so they're just not set up right. And so this, again, is a brand new requirement that requires you to actually test these systems to make sure they are operating as designed. And there are specific requirements that actually apply to occupancy sensor, time switch, and also daylight responsive controls. So if you get into this requirement or this section in the code, you'll see, if you have an occupancy sensor controls, here's the requirements to make sure that it operates, and here's the testing you have to do. But this will go a long way toward making sure that what's installed actually works as designed, and you actually get the energy savings that the code is trying to get out of these types of control systems. So, Howard, do you want to talk about submetering?
Absolutely, but just a comment on the previous slide. We could call this testing commissioning, because we do require HVAC commissioning and so forth, and we found commissioning to be one of the most effective means of achieving energy savings, because you'd find this very hard to believe, but from the time the architect sketches out a design to the time it actually gets installed, there may be some changes, and the changes may not be all beneficial. So this type of lighting testing achieves some very, very cost-effective savings. But to submetering, traditionally the National Code, in my humble opinion, has not addressed submetering adequately. And I use a good analogy of your own home. If you are a parent, say with teenage children, you are always reminding them to turn off the lights or get out of the shower earlier. Why? Because you're paying the bill. When you pay the bill, you pay attention to whatever is using energy. Likewise with tenants. We, in retail spaces or living unit spaces, very often there was just one meter for the entire building, and occupant A might leave the air conditioning on 24/7, while occupant B might be very, very conscientious about turning the AC and the lights on and off. Think, for instance, well, let's go to Waikiki retail shops. You go to your high-end, or any shopping mall for that matter, go to your high-end stores, and they have lights splashed everywhere, and the AC turned down to sub-freezing, and the doors open to invite the customers in more readily, and they might run 16 hours a day. And let's say they have 1,000 square feet. Right above them on the second floor might be a standard business office, fluorescent lighting. The occupant comes in at 7:30 in the morning, turns the lights on, the AC goes on at that time, and everybody is out of that space by 5:30 in the afternoon. And again, they've just used fluorescent lighting and very limited AC use. If both of those occupants, under traditional building protocols, both would get billed just on their square footage, whereas you know that the retail shop is using multiple times the amount of energy. So enter mandatory submetering. This is Hawaii specific. I tried to get the space down to 500 square feet or even 300 square feet, because that's what a lot of retail shops in crowded areas occupy, but I couldn't get it any further down. So the submeter doesn't have to be this big old-fashioned meter sitting around in the space. The submeter can be in the building manager's office, and just the tenant would be free to come in at any time during the occupied hours and actually read his or her energy use, and it would be incumbent upon the building manager to bill each of the spaces according to their real use. I think that makes perfect sense. So that's about enough of that, Eric.
So Howard, do you want to take this one, or do you want me to?
Yeah, no, I'll do this.
Okay.
Finally, in devising the national codes, we realized that an additional energy savings potential was to let each building designer pick his or her own additional package, because all buildings are different, all designers are different. And if we could go, so we said, yes, we're going to put this in as a separate section, and let's go to the requirements themselves. So the designer needs to pick, Eric, advanced slide.
Okay.
The designer needs to pick just one of these, in addition to all the other requirements we've seen. We've talked about advances in HVAC efficiencies, so the first option might be easy. You can just go up a couple of SEERs and achieve another easy 10-15% improvement in efficiency. Especially easy, as we've been talking about earlier, is reduced lighting power density. That is almost like falling off a log these days, and I would reiterate again, the less lighting wattage you have, the less heat load you have, the easier the time the AC system has. Enhanced lighting controls, given the extremely low LPDs that we're achieving, more controls might not be all that cost effective. And then on-site renewable energy. We all live in Hawaii, and we see PV panels here, there, and everywhere. And they work especially well here because our winter sun is so strong. And if Hawaiian Electric can figure out how to integrate all this new PV into their system, then getting a permit for additional PV will be hopefully easy. That's a totally viable option there. And incidentally, wind energy is not here yet, but it's coming down the pike. There's improvements, and the permitting is getting a little bit easier for wind energy. dedicated outdoor air system probably doesn't work too well here in Hawaii because of the humidity we have. And finally, high efficiency SWH, we think of that as solar water heating, but in fact this is service water heating. And again, the code specifies certain minimums for electric heating and for gas heating, but there are other models that can bump that efficiency up by 10 or 15% or so. Anything to add to that, Eric?
Actually, yeah, Howard. I was just looking at
Yeah.
the enhanced digital lighting controls and looking at the requirements to meet that in the IECC. And actually, I think that I mentioned earlier the luminaire level lighting controls. That actually installing that type of system would probably comply with the enhanced digital lighting control requirements, because one of the requirements is that each luminaire is capable of being addressed individually, and those controls are essentially installed on individual luminaires. So anyway, that would be an example of a system that would actually comply with the enhanced digital lighting control requirements.
Mm-hmm.
So what we're seeing is that a lot of, especially with the lighting power density requirements that are in the code right now, the reduced lighting power density we feel is probably going to be the most popular selection, just because it's easy to comply with the what's currently in the baseline code. And the 2018 code, I think the requirements, the provisions they put in to try to change that are going to reduce the lighting power densities down another 15 to 20% across the board. So
That's my memory, yeah.
yeah, so right now these requirements are only going to require a 10% reduction over what's currently in the code. So I think the general feeling is that reduced lighting power is probably going to be the easiest thing to comply with for the additional options packages. So great. So that wraps up the presentation for today. If you have questions, and again, Howard and I, we like lots of questions. So the more you still have the opportunity to go ahead and email in some questions. I do have a couple of questions that have come in that we'll go ahead and answer right now. One is actually dealing with existing buildings that we didn't really talk too much about, other than we mentioned there's an existing building section in the code right now, but lighting alterations I think are probably one of the biggest. If you're going to modify or alter a existing building, it seems like lighting seems to be the one that comes up the most often.
Mm-hmm.
And the question is if I go in and do a lighting alteration, do I have to bring the entire lighting system up to compliance with the energy code?
And I can answer that initially. No, only what you touch you must bring up to code. For instance, if you're in a multi-story building and the tenant moves out of one floor and a new tenant moves in and wants a whole new lighting system, only that floor needs to be brought up to compliance.
Okay, so I'll ask a follow-on question to this, Howard. Then, if I'm only changing out the luminaires and I'm not touching the controls, am I required to make the controls comply to, or just the luminaires, just the lighting power density in that space?
Good question. My guess would be that you would need to install the controls also.
Okay.
That's a guess.
Okay, and that's going to have to be, that'll be a Hawaii interpretation on that. So typically the way I look at it, I liked your first comment. If you touch it, you have to comply. And I've kind of lived by that mantra as far as lighting goes, or any kind of an alteration in a particular building. So, and I'm kind of looking at there's obviously a lot of exemptions for alterations. And that one of the exemptions is that if you replace less than 50% of the luminaires in a space, provided that the alterations do not increase the installed interior lighting power, you're actually exempted from the requirement. So I guess, in other words, if you're actually making the system more efficient instead of less efficient, then you're exempted on that, which is, so there's not a penalty for actually making your system better.
Good point. Yeah.
Yeah. So if you want to change out, if you're trying to change out fluorescent to LED lights and you're making your system, a lot more efficient, then there's up to a certain point you can do that without having to worry about complying with the other provisions of the code. So yeah, you need to. The existing lighting section right now, or existing building section, actually has a pretty good roadmap into what you have to comply with or not have to comply with when you're doing a lighting change up. But again, that they seem to be the most common right now, and it's always kind of a question mark on what exactly you have to comply with from a code standpoint. So anyway, that's one question. The other one, and this I've seen this question before, is a lot of times if we're using the word functional testing in the code for lighting controls, but I think Howard used the word commissioning, which is kind of the same thing. The question is a lot of times you can't actually get these systems set up properly until after the building is occupied, and you get the occupant in the space because they bring in furniture, and you don't know colors and things like that in the space, so you can't really get them very well set up, and so this actually happens after certificate of occupancy. Is there going to be any allowance in the code to be able to get these set up following certificate of occupancy, or does it all have to be done prior to certificate of occupancy?
That's a good question for you.
Oh. Well, okay. So when I'm looking through here, and I've tried to think about this before, if we're looking at mechanical commissioning, a lot of times we're kind of in the same scenario there, where a lot of times the mechanical commissioning can't happen until you end up you're tinkering at the system, tinkering with the controls, making sure that everything gets set up right, and a lot of times the final commissioning isn't done until after the occupant's in the space, and then the functional, all of the commissioning reports end up going to the building owner. In a way, it's very similar to, and actually, as I'm looking through the code right here, let's see, there's nothing that really says that you can do that for the functional testing for lighting, but it seems like the same type of criteria should be met. That in some cases, you can't do the proper setup and testing on those systems until the occupant gets in, and so that's going to be after certificate of occupancy. And so you're kind of the final functional testing or report that comes with that may not happen until after certificate of occupancy. So it seems like kind of a reasonable thing to allow from a jurisdictional standpoint. They get some kind of documentation from who's ever doing the testing on this and setting up the controls that it's been done. The building owner gets the same documentation. I guess my answer would be it sounds reasonable to me that you want to make sure this is set up right, and if it can't be set up right until actually someone's in that building, then it makes sense to allow that to happen. But I know from a jurisdictional standpoint, the last thing you want to do is deal with something after certificate of occupancy. You kind of want to close the book on that project. So.
Yeah, let me give an example of that. A friend of mine who's an electrical engineer was designing a refurbished retail space that included a bathroom, and she designed the plans called for very light colored walls, fairly light colored floor and so forth, and she designed according to IES guidelines. And after occupancy, she got a call, there's not enough light in the bathroom. And she said, what do you mean? And she went to the site, and the bathroom walls and every possible, and the fixtures, everything was black. He said, what in the world is going on here? And the owner said, oh, I hired an interior designer and he loves black. So in this case, she was able just to increase the wattage and get adequate light down despite all the black interior there. That's a good anecdotal example.
Yeah, great, good. So we've got one last question, and I had mentioned in the talking about daylight responsive controls I guess we have one more coming in too. Daylight responsive controls, that there's requirements in the envelope requirements that actually requires you to put in skylights. And there was a question about, is there more detail on that? And so basically, if the way the code reads it, if you have in an enclosed space greater than 2,500 square feet in floor area, directly under a roof, not less than 75% of the ceiling area with the ceiling height greater than 15 feet, you need to have skylights. So you've got a space 2,500 square foot or greater with 15-foot ceiling heights. And the spaces that the code is looking at are office, lobby, atrium, concourse, corridor, storage space, gymnasium, exercise center, convention center, automotive service area, space where manufacturing occurs, non-refrigerated warehouses, retail stores, distribution and sorting area, transportation depot or workshop. Essentially, all of those spaces in large roofed areas, you have to have skylights in the space with automatic daylight responsive controls underneath the skylights. And as Howard and I talked about, I guess it was 2 days ago in the envelope, we're already seeing a lot of big box stores doing this. I can think of a Walmart, for example, Home Depot, I believe is doing that. But there's been kind of a shift to bring in a lot of natural light in these big box stores with automatic daylighting controls underneath there. So this is kind of the shift. So anyway, that's the requirement for the envelope, and this does require that you the lighting designer and the architect coordinate fairly closely on the design of the building to make sure it complies with the requirements. Okay.
Eric, let me jump in on that one too. I was in Austin, Texas at a convention some years ago, and we were given a tour of a brand new elementary school that had absolutely beautiful daylighting, because studies have shown that kids perform much better when their spaces are lit by daylight and they have views of the outdoors. So the building owner proudly marched us through classroom after classroom, recreation room, and so forth. And after the tour was gone, this was a nice sunny summer day, and after the tour was over, I took him aside and said, "Did you notice that the artificial lights were on in every one of those buildings?" And he just about melted through the floor. He said, "Yeah, I was hoping nobody would notice." Which is a case in point. People automatically turn on lights. If you don't want them turned on, if you have good daylighting, you must have controls for daylighting only.
Okay. Okay, one other question came in, and actually 2 more questions came in. The comment of great few days of webinars, extremely informational. Thank you. Is there a way to become certified in the IECC, for instance, as a third-party reviewer for small remodels and single-family dwelling? And I can take this one, Howard. So basically the requirement, yes, you can actually become an IECC certified on the commercial side, Energy Code Plan Reviewer or Energy Code Field Inspector. There are two International Code Council tests that you can actually take to get your IECC certification on that. And on the residential side, it's a combined plan reviewer and inspection test that you can take for residential. So yes, you can actually do this. I know the exams. I've taken the commercial test on the plan review side, so I know the exams are out there right now. You have to find the testing center, and I'm sure you could ask. I'm sure there's testing centers in Hawaii that you can go and test. And I can't remember the company that actually runs the testing for the International Code Council, but there certainly are exams. If you want to take the test, actually the information is out on ICC's website. It's actually iccsafe.org, iccsafe.org, and that's where you can order code books and everything else. So that's where to go to look for that.
And ICC encourages. They want more people to become certified, and to my knowledge, there are very few certifiers here in Hawaii. And as a result of this code this is going to be a growth industry. So I would encourage test taking.
Great, good, yeah, it makes sense. I mean, because that way also I mean, that's the best way to learn the code is by taking the exam. So it's a pretty rigorous test. So let's see. There's another question on Howard. You talked about lighting power densities, and in the 2006 code, there's additional allowances for retail lighting. For specific display lighting, are those similar allowances in the 2015 code?
I don't believe so. I wouldn't put my house on that, but I think that got eliminated because, again, LEDs are so darned good at, we didn't discuss this, at directionality. And generally, in the high-end retail, you want to highlight the article of the day that you really want to sell, and giving either very broad directionality or narrow directionality with LEDs is really, really easy. So I think that additional allowance for retail went away.
Okay,
if we have something else to talk about, I'll flip through the code to a certain yeah.
Actually, if you want to flip through the code, because I've got another question in here that deals with what happens if a top light and side light zones overlap? That's a great question. Can the overlapped zone share the same control? And let me, I believe the answer to that is no. Let me just look in here because the code does, but let me dig into this really quick to see if I can actually find the answer to that one. I know that if you have side lights, you need a separate control, for example, for each orientation, because of the sun, the way the sun comes in. So every orientation, every daylight zone on a different orientation will have to have a different control to do that. For top light and sky and day, and I think that you can have a single control underneath several skylights. But I'm not seeing what happens if they. I don't know that the code addresses if you have an overlap between top light and skylights. Yeah, I need to actually. I have the email address for that came in, and I need to look at this one a little bit closer, and I'll go ahead and email the answer to whoever asked this particular question. So, because it is a great question, and it's definitely something that is that happens all the time. So. Great. Okay, Howard, were you able to find the answer to the?
Yeah, I was. There's no special exemption for retail areas anymore. The closest space by space I could find was sales area, and that is just 1.59 watts per square foot. So again, I think the rationale is that you can, even in high-end retail, you can highlight exactly what you want.
Okay.
Just have a very low level of ambient light otherwise. So the 1.59 would suffice.
Okay, yeah, because I'm just looking at, I've got my code book open too as I was trying to find the answer for the overcross for daylight zones. And I did see, Howard, on section 405.4221, additional interior lighting power.
Okay.
Yeah, it looks like as I'm reading through here, they actually do give a little more allowance for that. But it looks to me, if I'm reading this correctly, you have to use a space by space method in order to get that.
Oh yeah, this is familiar. What they're doing is differentiating between square footage, on the assumption, I think, that the smaller the square footage, the more likely you are to be high end. So the smaller the footage, the greater the LPD allowance.
Okay, great, good. So we got the answer on that. That's the key. So that is the last question. We appreciate all your questions coming in, and with that, I'm going to turn this over to Howard to kind of wrap things up. So.
Yeah, let me thank you all for attending, and thank you for great questions. With more questions, there is my email address. For each of the webinars, several of you have come in with very specific questions, and I've appreciated that. And now this is the last of the webinars. Now Eric's firm will be compiling all of the questions and putting that on the website, or giving us the summary of the questions, and we'll add that to our existing frequently asked questions sections on the State Energy Office website. And also all of these webinars will be going up on the State Energy Office website. Oh, and finally, if you are architects out there wanting continuing ed credits, this is something we should have addressed right up front, just email me your name and the tell me the webinars that you attended, and we'll get you your credits there.
Great.
And I believe that's it.
Great. Well, thank you everyone for attending. We appreciate your great questions, and those of you that actually attended all the webinars this week, we appreciate your attendance. And even if you didn't, we think it's great. Anyway, great. That's all I have, Howard. And I think we're all. Thank you very much again, and it was great presenting with you over the last few days. So,
likewise, and for all of you out there, stay tuned. The IECC 2015 is coming to a county near you. Sooner the better. Thank
great.
you.
All right, thank you. Bye.